The town of Barnstable's water supply division was created by town council in 2005. The move followed the acquisition of the Barnstable Water Company, which was previously privately owned. The water supply division is responsible for management of the water distribution system used by residents and businesses in Hyannis. The water supply division is an enterprise-funded account within the Department of Public Works. The water supply division's infrastructure system consists of 2 water treatment facilities, 12 well pumping stations, a number of which have self-contained corrosion control systems, 4 water storage tanks, and approximately 107 miles of distribution piping. We got a chance to tour many of these facilities with Water Division Supervisor Hans Kaiser. We stopped by the water storage tanks off of Mary Dunn Road first on our tour. Kaiser says water storage tanks are an important part of the water supply division.
It works like a buffer, so especially when all of a sudden if you have a water main break or a fire, then all of a sudden you need a large volume of water, and the pumps will not be able to keep up with that. So that is why you need water storage tanks. That's one of the reasons. The other reason is the system, the way we turn on and off the pumps are based on the water levels in these tanks. So the moment the water level in these tanks goes down, we turn on automatically pumps, and if it keeps on going down the water, we turn on more pumps, and then the moment the water starts rising, slowly, one by one, we turn off the pumps. So these tanks are very important for those 2 reasons.
The town's oldest water storage tank is more than 100 years old.
It was built in 1911 as part of the original construction of the water company. They call it the Barnstable Water Company at that moment. It's 100-foot high, has a wooden roof and steel riveted tank.
Kaiser says the water supply division hopes to make some improvements to the tank in the near future.
It's time to change that. It's been in the planning for quite a few years, and we're planning to change the roof to a domed roof and a stronger roof, and at the same time we would like to repair the foundation and fix the site, make it more secure and more updated.
One way the water supply division tries to keep rates low is by renting cell tower space to cell phone companies.
We actually have 2 cell companies that lease space on our site and on our tower, and it brings in close to $100,000 a year on revenue, so that will give the customers of the Hyannis water system some rate relief.
Kaiser says the water supply division has made many improvements since acquiring the company in 2005.
A lot of the facilities were starting to wear down and needed some serious capital investment. Not only the storage tanks, but also the treatment plants, the well sites, and especially, we have over 100 miles of pipe in the town. Lots of it is 100 years old, and that needs to be upgraded, replaced, just to keep up with things, because pipe, everything doesn't last forever. You got to maintain things, and you cannot replace 100 miles of pipe in 1 or 2 years. It takes a long time and very expensive, so you have to spread it out over a long time and do little at a time.
Another improvement the water supply division has been focused on is replacing out-of-date generators.
And the emergency generator will take care of the powering of this facility, just in case we have a blizzard or a hurricane. Great. A lot of the work we do and we have been doing is preparing for exactly that. When the town bought the water company in 2005, we had very minimal amount of emergency generators, not really prepared well for contingencies like that. It's one of the first things we did is invested fairly heavily in providing redundancy and emergency power. The fire department really relies on us to provide water with enough volume and pressure for them to fight fires. And especially in hurricane or after hurricane situations or blizzards, when there's a fire, the fire hydrants have to work no matter what. And there's basically no excuses. So we have to provide that. We need emergency generators, we need storage, we need everything we do to fulfill that support function for the fire department.
The next stop on our tour was the Mary Dunn Water Treatment Plant.
This treatment plant, just like our other treatment plants, what happens here is the water that comes from all the wells gets collected right here and through pipes, runs through here, and it gets injected with all the different chemicals. And each length of pipe is called a train, a treatment train. So you start injecting one chemical, then you wait a couple of feet, 10 feet, then another chemical gets injected. Then we have valves and measuring tools, measuring equipment on it. Each pipe comes from different wells, and they all get treated with the same amount of chemicals, the same way, the same concentration, and then it goes, after it goes through this building, then it gets all manifolded, all put together, and then it goes into that large 16-inch water main that's underneath the road that goes into Hyannis or back up to the tanks.
So I think now I have a better understanding, because I see where the chemicals probably would be injected.
Right there. Yeah.
And right there near the end.
Yeah, exactly. Yeah, the last one is chlorine before it goes out. Okay? And on this one here is a phosphate that basically deals with corrosion control. It coats, it's like a food grade chemical. It's actually the same chemical that's in Coca-Cola and Pepsi and stuff like that. It basically forms a little teeny weeny coat on the inside of the pipe to protect it from corrosion.
Wow.
Okay. And over here we have the chlorine analyzers for all the different wells and different treatment plants, and they automatically test the chlorine and then transfer it into like a signal, and that goes into the computer.
Wow. And you can see the level right there.
Yeah, yeah, and that level gets also transferred via the radios back to our office. So on our
you can
central
see
computer,
the levels of the chlorine in the water.
Yes, everywhere.
Recently, the Environmental Protection Agency tightened regulations regarding emerging contaminants like PFAS and PFOA.
The EPA required testing in 2013 and 14. That was called the UCMR 3. We found two different substances that were a problem. One was the PFAS PFOA issue, and the other one was the 1.4 dioxin issue. We had to actually turn off or minimize the use of 3 wells, 2 at Mary Dunn and 1 Maha well. And what we did is we ended up putting carbon filtration systems on the Mary Dunn wells.
Kaiser described in detail how the carbon filtration system works.
These 2 vessels basically treat the water from Mary Dunn 2. You have what they call a lead vessel and a lag vessel. So both vessels are filled with activated carbon. The water gets pumped through both vessels, first through one, the lead, and then through the lag. So what happens is the lead vessel will take the bulk of the material out, the contamination, the PFAS, PFOA in this case. And then if there's anything left over for whatever reason, the second vessel, the lag vessel, will take the rest out of it.
Interesting.
And what we do, and then it goes through the treatment plant, and then it gets injected with all the chemicals that we are required to do, and then it goes into the system. And what we do is we test, or we sample every month. Before it goes into the lead vessel, in between the lead and lag vessel, and after. And we check it and make sure that the contamination levels are down. And then what happens is, over a long period of time, eventually all the activated carbon is going to be used up because it takes up this contamination. And then what you see on your test results, the levels slowly go up. But you still don't have to worry because the water goes through the lag vessel too. That will take care of it. So what you do is then when it gets to a certain point, you basically shut this vessel down, empty it out, the used up carbon, you emptied it out, you put new activated carbon in, and then you flip-flop the vessel, so the flow will be flip-flopped. Then all of a sudden your lag vessel becomes lead and eats up basically all the contamination, and then it goes to the lag vessel. That's kind of like how it works in a nutshell. The amount of money that it costs to replace the carbon is just crazy, but that's what it is. It's about $35,000 to replace the carbon in one of these vessels. So if you had to replace both, it would be 35 times 2, it's $70,000.
Now, do we know how often that will need to happen, that the carbon will need to be replaced?
It kind of depends on what the carbon is and how much concentration of contaminants, etc., etc. These units have been running now 2 summers ago, last summer, all through the fall, through the winter, and we're just starting to see a little breakthrough in the lead vessel. So most likely we're going to have to replace the lead probably just before the summer. So it's really not bad.
Yeah, it lasts a long time.
Yeah.
Town Council recently approved funding for another carbon treatment system at the Marwell Field and Treatment Facility. To learn more about the Water Supply Division, you can visit the Town of Barnstable's website and click through to the Water Supply Division.